Hello and welcome to Crazy Math Productions. Today we're continuing our lessons, our unit on exponents, properties of exponents, and applications of those exponents. So basically today we're starting off with, we've got division properties. First of all, you can see that as we go through, let's see if I can zoom in here, say 3 to the 7th divided by 3 to the 4th. What's happening is this is actually repeated multiplication. So you're just going to have some things to divide out. 3 divided by 3 is 1. 3 divided by 3 is 1. Again, 1. Again, 1. So you end up with these 3 3s, or 3 to the 3rd power. The shortcut is just to simply subtract them, or to realize that there's 3 more 3s on the top in the numerator than on the bottom, the denominator. Now, you can also look at the power of a quotient. If you have a power with this, the division, the quotient there, you can actually distribute this. The long way is to simply use a Xerox, copy it 3 times, and go from there. The shortcut is to simply distribute it. It's not really a distributive property, but it acts like one. And you have 5 to the 3rd on top, 6 to the 3rd on bottom, and then simply work it out from there. Okay, let's try some. Okay, in this one, again, you could say 4x is on top. Excuse me, that's multiplication. 3x's below. So we have anything divided by itself is 1. Of course, assuming this is non-zero. Divided by itself is 1. Divided by itself is 1. There's one more on the top than on the bottom. So it's x divided by 1, or just simply x. Number 2, there's 2 more 6's on the top than on the bottom. So that's just 6 squared over 1. Since this is 4 or below, we could just go ahead and say that is 6 squared is 36, and division by 1 is just itself. All right. Here we have 4 more y's on the bottom in the denominator than in the numerator. So it's going to be 1 over y to the 4th, and that's pretty much it. Okay, and here we have 3 more 5's in the bottom and the denominator than in the numerator. So we're going to have 1 over 5 to the 3rd. Now, 5 to the 3rd is 4 below, so let's go ahead and work that out. 5 times 5 would be 25, times 5 would be 125. 125th. Here we're going to put this over 1, a to the 3rd over 1, multiply straight across. We have a to the 3rd over a to the 4th, and there is one more a in the bottom than in the top. You can kind of subtract these and you realize that there are more a's in the denominator than the numerator. So that's going to be 1 over simply a to the 1st, or you can just say 1 over a. Now, some people may say, well, you could just subtract this. 3 minus 4 would be negative 1. Problem is that's going to be referenced from the top. So if you do it this way, you have to, if you cut that with Crazy Math Productions, we do the Chuck Norris and move that to the denominator. So 1 divided by a, and you're going to come up with the same thing. Okay, and this is 3/4 to the negative 2nd power. So what I'm going to do, there's 2 choices here. The first choice, a little here, 3/4 to the negative 2nd power. The first choice is to simply sort of distribute this. So we have 3 to the negative 2nd over 4 to the negative 2nd. Again, Chuck Norris beats him down. He's not positive. He's not negative anymore. Uppercuts him through, and we've got a positive situation. 4 squared, that's 16. 3 squared, that's 9, so 16 ninths. We could leave it that way. Now, the other way to do it is to simply realize that there's this nice shortcut that can be done. When we have a negative exponent and a fraction inside, we can just switch these around. So 4/3 to the positive second, and then we're at the same place we were here. 4 squared over 3 squared divided by 3 squared. That's 16 ninths. Excuse me. So 16 ninths. All right. Here, we're going to be very, very careful here. How many negatives are on the top? There are 4. So 4 negatives. Again, negative, 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 negative. These are going to be a positive. These are going to give me a positive. Positive times positive is positive. Again, there's an even number of negatives. That means that it will end up positive. If that were a 5, if it were an odd number, or say 7, if it were negative 5, in parentheses, to the 7th power, that 7 makes it an odd number, so that would end up negative. But as it is, so 5 to the 4th, because there were an even number of negatives. Same thing on the bottom, negative 5 in parentheses. If it were not in parentheses, the whole thing would be negative. Excuse me again. So there are 4 negatives. That leaves an even number of negatives, which means the whole thing is positive. 5 to the 4th power divided by 5 to the 4th power. Well, what happens when we have the same number on top as in the bottom? If we go with the subtraction method, that'd be 5 to the 0 power. What exactly is 5 to the 0 power? Let's investigate. 1, 2, 3, 4 5s. Same thing on the bottom. They divide to 1, again to 1, to 1, to 1. That's going to be 1. Anything to the 0 power besides 0 itself. 0 to the 0 power is undefined. But anything else to the 0 power is going to be 1. Unless there's a negative that's not in parentheses, in case it would be a negative 1. If that confused you, just a little side note here. The opposite of 5 to the 0, well, that's actually the opposite of 5 to the 0, which is 1, which is negative 1. So just to contrast that there, this is a little different situation, but nonetheless very important. Okay, so this is 7 to the 1st power. So if there's 7 to the 3rd, 1, 2, 3, 4 7s. There are 2 more 7s in the bottom than on the top. So 1 over 7 to the 2nd, or 1/49. Okay, last page here. 3/5 squared. Now, when these exponents here are smaller, I like to try to see if I can just use the little Xerox copy method. Take exactly what you see inside, make 2 copies of it. So it's going to be 3/5 times 3/5. That's going to be 9/25. Of course, there could have been a separate method there. 3 squared divided by 5 squared. And that's 9/25. So it doesn't matter which method you choose. Now, it does matter if this number gets to be very large. If that's, say, 50, well, you need to do this method because making 50 copies of this can be a little ridiculous. Okay. Number 10. Now, this is not a negative exponent. If you've kept up with the whole Chuck Norris thing, again, the Chuck Norris is just some scaffolding to try to help you to utilize that. What's going to happen here? Not a negative. This is just, this isn't a guy being negative to his girl. This is just a guy that's kind of depressed. And he's not just going to randomly beat up somebody that's depressed. So I'm going to go, since this is just a 3 here, I'm going to go with the Xerox copy method here. So I have negative 5/4. And then 1, 2, 3 copies of it. If there's 1, 2, 3 negatives, that's an odd number, so the whole thing's negative. 5 times 5 is 25, times 5 is 125. 4 times 4 is 16, times 4 is going to be 64, and we can just leave it that way. Now, if you wanted to, you could say this is negative 1 times 5/4. This would be a separate method. There's 3 of the negative 1s, 5 to the 3rd, 4 to the 3rd. So 3 negatives, that's going to give me the whole thing negative. 5 to the 3rd, 125. 4 to the 3rd, 64. And you see we have agreement here, so that's fine. All right, we could do the Xerox copy method. The problem is we're getting a little large here. 4, 5, 6, 7, starting to get a little large, so I'm not going to use the Xerox copy method. I'm going to say 1 to the 4th over a squared to the 4th. Well, 1 to the 4th is just 1. 4 sets of 2a's. Well, 4 sets of 2, that sounds like multiplication. That's the concept. 4 sets of 2. It's 2, 4 sets of 2. That's 8 altogether. So a to the 8th power. And that's 1 over a to the 8th. All right, and now we start to get into the harder problems. The number 12, I'm going to simply go through, I'm going to treat 7/14 like sort of an embedded fraction. 7/14 can be reduced to 1/2. So I'm going to start off my fraction with the 1 on top, 2 on the bottom. Now I search through x squared over x to the first. Let's see, zoom in a little bit more. You can see x to the first, x squared. There's one more x on the top than on the bottom. Y to the third over y to the fifth. There's 2 more y's on the bottom than on the top. And of course, 1 times x is just x. So x over 2y squared. And there we have it. Okay. Number 13 here. 8/12. Let's see, we can reduce by 2 will give me 4/6. Reduce by 2 again will give me 2/3. So I'll start off my fraction, 2/3. Okay, now the negatives. I've got to take care of these before I start reducing. To the negative second, he's been negative to Chuck Norris's girl. He gets booted to the bottom. So we have x to the 4th that was there. X squared will join. He's gotten booted to the bottom. Y to the negative third, he's going to be uppercut through the top. Y squared remains. So we just need to combine these together and we'll be ready to go. So 2 times, see, 1, 2, 3, 4, 5 y's. 1, 2, 3, 4, 5, 6 x's. 2y to the 5th over 3x to the 6th. We're ready to go. Number 14. A lot going on here. Let me just sort of get you inside my head. A little bit dangerous place to be. We're going to look at this -4 here. That's the first place where my eye is drawn. Now, I'm going to take care of this first. I'm going to boot it down into the bottom, copy everything else. Now, I don't have, for example, if you look in 15, this is the first place my eye would go. We don't have anything like that in this problem. The second place my eye is going to go is to these negative exponents. So I have no negative exponents. I don't have any exponents outside of a parentheses like this. So now I can start to begin to combine. Now I'm going to combine across horizontally first. You don't have to do that. You could do vertically, then horizontally. It doesn't really matter. So I'm going to combine horizontally first. So 7 times 4 is 28. X squared times x, that's 1, 2, 3 x's, x cubed, and the y to the 4th, over, let's see, 2 times 1 is going to be 2, y squared, let's see, we got the x to the 5th, 1, 2, 3, 4, 5, 6 y's, and now we just need to look. Let's see, divide by 2, that'd be 14 over 1, don't necessarily need the 1. There are 2 more x's on the bottom than on the top, so I'm going to put the x squared on the bottom. There are 2 more y's on the bottom than on the top, so put the y's down here. And we have 14 over x squared, y squared. And that's it. Okay, number 15. Be very careful. We don't want to have a situation where you're just going to be completely overwhelmed. So what I'm going to do is I'm just going to focus on this. I'm not going to worry about anything else. I'm just looking here. So literally, You can put your, take your thumb. You want to narrow the scope of the problem that you're looking at. You want to try to see if you can make the problem as simple as you possibly can. So I'm going to ignore all of that for the moment. I'm worried about this. I've got to take care of this before I can do anything else. So 3 to the third, oops, wrong pen. 3 to the third, x to the third, y to the third. All of this. I'm not even going to worry about this yet. I'm just going to work on this. 3 to the third, that's 3 times 3 is 9, times 3 is 27. X to the third, y to the third, over negative 9, x to the third, y to the third. So this is at least to a point where it's manageable. So I'm going to bring this back. We're just going to bring this down. Okay, so now I'm just going to look at, you see, there's a lot of stuff going on. I'm just going to look here. There's no exponents outside of a parentheses like this. There are no negative exponents like this. Everything looks good. I can combine across now. So I'm going to combine horizontally. Remember, this is multiplication. I should have written that in. So now we're going to combine across. So I'm going to go up right here. Negative 2 times 27, that's going to be negative 54 times, let's see, 6, 7, 8, 9 x's, 4, 5, 6, 7 y's, see, negative 9, 4, 5, 6, 7 x's, see, 2, 3, 4, 5 y's, and now I can combine vertically. So negative divided by negative is going to be a positive. Not that I need to put that, but we'll put it as a reminder. 54 divided by 9 is going to be 6. So we've got 6 over 1. I don't have to put this 1. So, well, I'll tell you what, we'll go ahead and put that on. So 54 over 9 is going to reduce to 6 over 1. And just a reminder, that's all multiplication. See, there's 2 more x's on the top than on the bottom, so we'll put x squared in the numerator. There are 2 more y's on the top than the bottom, so we'll put y squared in the numerator as well. Now, there wasn't anything else on the bottom to deal with besides the 1. I'm just going to put the 1 here. Anything divided by 1 is just itself. So 6x squared, y squared. Okay, last but not least. Okay, couple things that I see. Number 1, I have to deal with this, to the negative second power. After I deal with that, I have to deal with the y to the negative fifth, x to the negative second. We're going to have to deal with this in stages. First of all, I have to deal with this. Now, Chuck Norris isn't afraid of having a big group. In fact, the whole group is being negative to Chuck Norris's girl. The whole group is going to get bam down to the bottom. Now, we can't have nothing here. 0 would literally make the whole thing 0. So we're going to put a 1 for the holding place. Now, we did the 1 thing here. I don't see any problem with going ahead and dealing with this as well. The x to the negative second, we're going to have to move this down. Let me go ahead and put 4. The y to the 6 is cool, so he's going to stay put. The x to the third, he's cool, so he's going to stay put. The y to the negative fifth, he gets uppercutted. X to the negative second gets beaten down. And so we have a problem we can deal with. Now, if you're looking at this problem here, if I look at this problem, I immediately look here. I can't do anything until I work on this. Well, technically, you could work on this part, but I'm scared students may try to simplify something that's inside these parentheses with something that's outside. So just for safety here, please be careful. 3 squared times x squared times y to the 4th squared. And of course, times x squared times y, and the 1 on top. There's no reason we couldn't go ahead and combine these. We've gotten this out. We haven't tried to combine this with something outside. That would be a huge mistake. So I feel comfortable. We could go ahead and do these. Y to the 5th, y to the 6th. Together, that's y to the 11th. On the bottom, 3, 4, 5 x's. And now, narrow the focus of what we're doing here. Okay, this 3 to the squared, that's 3 squared is 9. By the way, I'm combining across here. 3 squared is 9. Let's see, we've got x to the 5th, x squared, x squared. 1, 2, 3 sets of x's. Y to the 4th squared, that's 2 groups of 4. So 1, 2, 3, 4, 1, 2, 3, 4, 2 groups of 4, that's 8 altogether, that's multiplication. So y to the 8th, we also have one scraggly y out here that's doing his thing. 4 times 1 is 4 on top. Y to the 11th times 1 is y to the 11th. And again, narrow the focus. Okay, first things first. 4/9, that is as simplified as it gets. This is a mess down here. Let's clean that up. 5, 6, 7, 8, 9 x's. 8, 9 y's. And now we need to simplify things. Let's see. Y's vertically can be combined. There's 2 more y's on top than on the bottom. It's going to be 4y to the 2nd over 9, let's see, x to the 9th. And that's it. Hope you've enjoyed Crazy Math Productions for today. Thank you very much. Have a good day.